Okay. So till now, we have discussed about this. So after that, whenever we will reach the 5, so 5 means we have already reached all the vertices have been visited because 5 vertices are present and the value is 5. So that means we have visited towards all the vertices. So when all the vertices we already covered, then we will return to the first vertex again. This is the way that we can find the cycle. So now, after getting the value of 5 in the fifth index, we will put 0 here. Now, why we'll put 0? 0 means stop. That we have already covered all the vertices. So after 5, we will return to the initial value again. So that's why the initial value we have put in this index. The initial value is put into this index. Now, whenever this initial value we put in this index, we will check the previous one value again. Now, previous one, the value is 4. So, previous one value will be, it will be in the next previous one value, we will increase the previous one value. So, after 4, what came after 4? We already seen that after 4, 5 came. So, we will put 5 here. Now, after increasing the value and put the value that is 5 here, we will check with the previous value. Its previous value is 3. So 3 and 5 between them, is there any edge present? Is there any edge present between 3 and 5? We will check that is there any edge present between 3 and 5? So let's check into the adjacency matrix. So 3 to 5, this is 3 and this is 5. But no, there is no edge present. Here it is written 0. That means no edge is present. So if there is no edge present, that means we cannot consider this value. We cannot consider the value 5 here. We cannot consider this value 5. So it will increment again. Now after 5, we already seen that after 5, the what value it is came? After 5, the value will came 0. That means it is like that from 0, 1, 2, 3, 4, 5, and after completing, it will start again. That means after 5, it will be 0 again. Then after 0, it will be 1, then 2, then 3, then 4, then 5, and again 0, 1, 2, 3. Like this, it will be repeated. So that means we have already seen that there is no edge present. That means the next value, we will use the next value here. So the next value of 5 will be what? The next value of the 5 will be 0. The next value will be, after 5, it will be 0. So that means, you see, we have put the value, we have put our value 0 here. Here we put the value 0. So that means when we will get 0, we will again backtrack. We will again backtrack to the previous step. Now in this previous step, what value is present? The value is present 3. Now we will put the next value into it. After 3, what comes after 3? It comes 4. After 3, it comes 4. So we put the value 4 here. And when we put the value 4, and to verify that value, we verify it with the previous value. The previous value, we will check with the previous value. That means the previous value is 2 now. So between 2 and 4, is there any present? Between 2 and 4 in the adjacency matrix? Let's see that there is an edge present or not. there any edge present or not? We will see from 2 to 4 is an edge present. Yes, from 2 to 4 there is an edge present. Okay, so that means we will use this value. This value is correct. So 2 to 4 there is edge present. So the value we will consider. The 4 will be considered. Now after considering, it will check now the next vertex, because I have already considered because between 2 and 4 there is edge present. So that means we move now to the next index, and in this next index we will first try to put 1 here. Now we'll put 1 because after 0 what value came? 1. But you see 1 is already in the previous time it is appearing, it is already appeared. So that means we cannot put 1 here now. So next value 2 we will check, but here also the 2 is written. So next, what value? Right here 3. Let's say 3 is appeared previously. No, 3 is not appeared. So okay, we can put the value 3 here because 3 is not appeared previously. Now for validate that, what we have to check, is there any edge present between 4 and 3? Let's see it in the adjacency matrix, that is there any edge present between 4 and 3. So between 4 and 3, 4 and 3, yes, there is an edge present. So that means we can consider it. So that's why we are already considered this. Yes, there is an edge present. So we will able to consider that. So that means this value we have already put. So next, check the next index. Now in its next index, it is already 0 here. So in next index, we will after increasing, we can put 1. But let's see, 1 will not present. 1 we will not able to write here because 1 is previously appeared. Then 2 also check 2, because but 2 will also not able to write 2 here. 3 is also present. So we cannot write 3 here. In this, we cannot write 3. Then 4, but 4 is also appeared. So we cannot write 4 here. So next, we can write 5. Yes, 5 is not appeared. Till now, 5 is not appeared. So we can write 5 here. Now, after writing 5, we will check between 3 to 5. Is there any edge present? So between 3 to 5, let's see there isn't any edge present or not. Now in the adjacency matrix, 3 to 5, no, there is not any edge present. So if there is not any edge present, that means this value cannot be validated. This value, we cannot validate this value. So that means 3 to 5, there is no edge present. So we cannot validate this value. So the next value will be, it will be become 0 again, because 3 to 5, there is no edge. So take it as 0. So 0 means we will again have to go to the previous step. We have to go to the previous step. If it is 0, that means we have to go to the previous step. So going to the previous step means now we have to check in 3. Now 3 is incremented, so we have to increase the next value. It is increasing this next value, it will be 4, but we cannot take 4 here because 4 is already previously appeared. So that means we have to take 5 here. So let's see from 4 to 5. From 4 to 5, is there any edge present? Because whenever we'll write 0 here, whenever any index we will write 0, that means we have to move now to the previous index. So that's why whenever I write 0 here, because it is not able to validate, that's why we write 0 here. So whenever 0 will be there, that means move to the previous step. That means it says that move to the previous step again. So that's why we will again move to the previous step. So whenever we will move to the previous step, then after moving to the previous step, our first thing will be to increase the value. Our first thing will be increase the value. That's why we change the value 3 to 4. but we cannot take the 4 here because 4 is previously already appeared. So that's why 4 we cannot take. So after again we will increase and we get that we can take 5 here because there is no 5 present in this list. Till now there is no 5 present. So we can take the value 5 here. We can take the value. Now, whenever the value we will put, after that, we have to check that if there any index between 4 to 5, is there any index? So let's see, is there any index present or not between 4 to 5 through adjacency matrix? From 4 to 5, yes, there is an edge present from 4 to 5. So that means it is clear we can take the 5 value here. So we can take 5 now because there is an edge present between them. So whenever the edge is present, that means we can validate that value. We can validate that value. So here 5 we already taken. So after valid value, that means it will again move to the next index. Because we already validated the value, that means it will move to the next index. Now next index initially it is 0. So we will start incrementing it 1. Can we write 1? No. Then 2. Can we write 2? No. Can we write 3? Yes. Because 3 is not appeared till now, it is not appeared. So we'll put Okay, sorry for the delay, but network issue is going on, so that's why this problem is. We are till now the last thing we are discussing. Discuss that we will able to put now three value here. So whenever we will put the three value, that means we have to check, we have to validate that value. Validate that value means we have to check that there is any age present or not between 5 to 3. Is there is any age present? So we will move to see in the adjacency matrix there is to 3. No, that there is no age present. There is, we are seeing that there is no age present. So whenever there will be no age present, that means we will move to the next. We will put 0 here there because there is no age present. So instead of 3, we cannot take 3 now because 5 to 3, there is no age present. So if there is no age present, you see, we will put the value 0 again. So 0, whenever we will put the 0, that means we will have to move to the previous index again. So before again move to the previous index and increment. After moving to the previous index, increment the value. That means increment after 5, what value came? 0 value came. So here the value came 0 now. Now what we have to do after it 0 comes, that means again move to the previous index. So whenever we'll move to the previous index, after moving to the previous index, our first thing is the value. Now 4. So after incrementing 4, what value it will be? The value will be 5 because after 4, what value comes? 5. So that means we will see. Now we'll write. See, we have written 5 here. Have next, we will check the next. Now, so in next index, already it has 0. In the next index, it has 0. So next index 0 means now we will put the value. Can we put the value? We will, after 0, what value came? 1. But we will not take 1 because already appeared. 2, no, we cannot able to take 2 here also. Then 5, then 4, yes, we can take that. So here we are written 4 here. We in the index 5 to 4, yes, an age present. So that means this is valid. So we can take 4 here. It will move to the, here it is already validated. So whenever so here 0, that means incrementing 1. No, we cannot able to put 1. 2, no, 2 is already appeared. We cannot able to put 2. 3, yes, 3 can be placed because 3 is not appeared. Okay, so that means whenever we will put the value, we will again check the adjacency matrix that there isn't any age present or not. Between them, there isn't any age present. So move to that 4 to 3. For 4 to 3, yes, there is an age present. Okay, so 4 to 3, there is an age present. Now that means already all the values in the index have been filled. So now we have to check that from 3 to 1, can there is any age present? From 3 to 1, from 3 to 1, 3 to 1, yes, there is an age present. So okay, this is an another cycle from 1 to 2, 2 to 5, 5 to 4, 4 to 3, and 3 to 1. So this is our another cycle. This is the another cycle we get now. So that's how we have get the values. So that's how we have get the values now. So this is the way we can find the cycles. Okay, अब तक क्लियर है सबका कि साइकिल्स कैसे हम लोग निकालते हैं? समझ में आया?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, so it is not the last, because you can also again you can able to find that in case of again you will move, then increment it like this, another cycles you also verify, but I am not telling that, because there is many cycles. It may have possible, it may be possible that many cycles will be present. It may possible that more than one cycles are present. So I have first I have explained a cycle, then again I have explained this cycle. So like this way we can find the cycles one by one. Okay, so this is the way we are finding that. So now we will move to the algorithm. Now we'll able to, and I will show you that how we are performing this algorithm or performing this. So now we'll move to towards the algorithm. Now this is the algorithm. This is the algorithm of our Hamiltonian cycle. Already in the first class, I have already said that if you didn't able to remember, then algorithm is there is no bound of writing any language. If you can able to write in the simple English also, you can write. There is no bounding of that. Only using the step by step, explaining that what you are performing step by step, explain that with simple English language also. It, because if you able to explain, then also you can get marks. Okay, so this is the algorithm of the Hamiltonian cycle, algorithm Hamiltonian, and then again do operation next vertex. So we are calling another function that is the next vertex. So you see we are calling another function that is the next vertex, and in this next vertex algorithm, you are saying do xk equal to xk plus 1 mod n plus 1. That is the time I have already written that from 0, 1, 2, 3, 4, 5, then again 0, then again 1. So after performing the mod operation, you see already see that if 2 mod 2, we say 2 mod 2, it will be 0, like 3 mod 2, then it will be 1. So like this, it will again repeat. So in mod function, and after 4, it will be like this. So in the mod function, the values are repeated. So that's why I am in that time I am write like this. So in this mod function, these mod functions will perform and get the value like this. It will be increment the values. Then if xk equal to 0, we'll check that if 0 means that already we reached the stop position. If after that, what are the functions we are checking in the bounding? That no duplicate values can be taken. For checking the duplicate values, this is used for checking the duplicate values, this condition, that for j equal to 1 to k minus 1 do, if xj equal to xk, then backtrack. That means the duplicate value we find, that if the duplicate value is found, then we are backtracking. For checking the duplicate value, this conditions is used. And if after that, what we already always check, that is there, these conditions will check that is there any edge between or not. In that time, whenever the vertex, we are checking that whenever there is a vertex, there should be an edge. Whenever there is a vertex, there should be an edge from the previous one. So that means it will check that if there is any edge between them, if there is any edge between to the previous vertex and this vertex, any edge present or not. This if gx k minus 1, comma x k not equal to 0. This will check that there is any h present or not. So that's why it is written not equal to 0. That means the h should be present. The h should be present. And it will check that there is any h present or not. And this functions, if k less than equal to n, k equal to n, and gxn comma x1 not equal to 0. That means here we are saying that we have reached the last vertex. So whenever we will reach the last vertex, so after reaching the last vertex, what we will check there is any edge from the last vertex to the first vertex. Is there any edge present or not? We will check that. So this if will check that. So this is the algorithm of our Hamiltonian cycle. Okay. It is clear to everyone?
Yes, sir.
So this is about all about our Hamiltonian cycle concepts. So we have already covered that. First, we see that what is the Hamiltonian cycle concept. Then what Hamiltonian cycles in this some graph there may be possible that Hamiltonian cycles may be possible or not. Some graphs it contains a Hamiltonian cycle. It may also possible. Or some graphs we have already seen that the graph in which the articulation point is present, or the graph which has the pendant vertex, in that the Hamiltonian cycle doesn't exist. And the approach or the way we find through our Hamiltonian cycle, that is the approach that using a graph will be given a adjacency matrix and there will be an array present. And initially in the array, the values will be zeroed and incrementing the value. And whenever we'll reach the 0, that means we'll check the previous value. So like this, our Hamiltonian cycles will find. And this is the algorithms of the Hamiltonian cycle. Okay. So basically maximum algorithms we have already covered. So some algorithms are already left. So I will, before that, I will explain that. And after that, the important topic that is left, that is our, we called as the NP hard, NP problems, NP completeness, or the NP hard, NP click problem like this. This is the section of the algorithm. And this section, that NP completeness or NP class problems, that is some research based concept, it should be used there. So last, after completing all the algorithms, I will explain that. So then it's okay. I am ending the session then. So if anyone think that anyone has any questions, then ask. Otherwise, I will end the session. So thank you, everyone.
Thank you, sir.
Thank you, sir.
Okay. So I'm stopping the session.